Good morning to everyone. My name is Ramesh, Assistant Professor, Department of Commerce and Management, Soundarya Institute of Management and Science, Bangalore. Now I am going to explain Bangalore University under the BBA courses of Aviation Management, Unit number 1 of Operation Research, Introduction to Operation Research. In last two videos, I explained about that Operation Research theoretical part and formulation of LPP. Now I am going to explain LPP problem solving by graphical method. Now I am going to explain the problems how to solve the LPP problems. Now LPP problems how to solve in graphical method. Graphical method of linear programming. Two decision variables is there. We can solve by graphical method. If it is more than two decision variables are there, so we cannot be able to apply graphical method. Then we have to go for the advanced method. But we don't have in the syllabus. We have only graphical method. Here you see that the problem of three dimension can also be solved by this method, but their graphical solution becomes complicated, so that we cannot able to study because it is a three-dimensional format. We cannot be able to feel and realize the three-dimensional format. Steps in graphical method algorithm. What are the methods will be used for solving the graphical method? Formulate the mathematical model of the given linear programming problem. In short, we'll write LPP. Already explained that. How do you format the linear programming problem? First, we need to select the decision variables. Then, whether it is maximize or minimize, we need to find out. That is called objective function. Then, according to the conditions of the given problem, we need to make a constraints. Then finally we need to make as, what is that? We need to make as non-negative variables, that is called decision variables, always greater than or equal to 0. There, based on that, we are going to solve the graphical method. Step 1. Formulate the mathematical model of the given linear programming problem. Then treat inequalities as equalities, and then draw lines corresponding to each equation, non-negativity restriction. It's mean we need to find out each inequality, convert as equation, then we can find out where it is intersecting x-axis and y-axis. Then we can make whether it is greater than or less than. Then you can continue. You can find out. Locate the points, endpoints, or that is corner points on the feasible region. Feasible region means common region for the given constraints. Determine the value of the objective function corresponding to the endpoints or corner points. According to that, then we have to find out maximum or minimum we can take. Find out the optimal value of the objective function. We have to find out the z value, that is objective function condition should be satisfied. Then this is a problem we are studying. Here you see maximize. If it is maximize is given, we need to consider as maximum value. If it is given minimize, we can consider as minimum value. Maximize z equal to 18x1 plus 16x2 subject to 15x1 plus 25x2 less than or equal to 275. 24x1 plus 11x2 less than or equal to 264. Conditions is x1 and x2 value will be considered as non-negative values. That means first quadrant. We know in graph there are 4 quadrants will be there. positive is the first quadrant, and then negative and positive will be the second quadrant. Both are negative in x and y values are third quadrant, and then positive and negative will be the fourth quadrant. But we need to consider only in the graph first quadrant. That means both are positive values. That is the reason here is given x1 comma x2 is greater than or equal to 0. Again I will tell you, here only two decision variables only we can able to solve this problem. If it is more than that, this method is not suitable. Solution. Here you see, what is that? The two inequalities in the curly braces or the constraints. They are the plane that the mark of the feasible region. The formula z equal to 18x1 plus 16x2 is the optimization equation. I need to find the corner points of the feasible region. That means common point. How to find? We'll check with one way. First step to solve the inequality for the more easily graphed equivalent forms. Here you see the inequality will be written in the equation form. 15x1 plus 25x2 equal to 375. First constraint we are considered. In that we have to put x1 equal to 0. Always first variable we will put 0. We will find out second variable value. Then second variable we will put the 0. Then we will get a first variable value. That is the two ways we have to find out. So first x1 equal to 0, 15 into 0 plus 25 into x2 equal to 375. It's 0 into anything 0, so 25 x2 equal to 375. X2 equal to 375 divided by 25 will get 15. That is called, first point will be a of x1 comma x2 equal to a of 0 comma 15. Similarly, we need to find x2 equal to 0. When x2 equal to 0, if you substitute 15x1 plus 25 of 0 equal to 375, then we'll get 15x1 equal to 375. Then x1 equal to 375 divided by 15, then x1 equal to 25. Therefore, the second point is b of x1 comma x2 equal to b of 25 comma 0. There are 2 points. Each constraint will get 2 points. So first constraint 2 points we got it. This one we need to plot in the graph. If you use the graph sheet, we will be getting in this form. See that here the values or maximum will be, what is that? We'll get 25. Minimum will be 15. So x-axis I have taken as 2 units, y-axis also 2 units, because it will be lengthy, so I need to make a arrangement within the graph shape. So you have to follow that. This is less than or equal to constraint towards 0 will be considered. This is a graph will be followed. This is a first constraint graph. A point is 0 comma 15 we consider, and then B point is 725 comma 0. We can use the line join will get. This is a first step. Then we'll take the second constraints. 24x1 plus 11x2 less than or equal to 264. The inequality, this is called inequality, we convert as a equation. What is that? 24x1 plus 11x2 equal to 264. Here we know very well, first variable, that is x1 equal to 0 will be substitute. Then we'll get 24 of 0 plus 11x2 equal to 264. Then 11x2 equal to 264. Therefore, x2 equal to 264 divided by 11. Simplify, we'll get x2 equal to 24. Therefore, the third point C of x1 comma x2 is 0 comma 24. Similarly, x2 equal to 0, you can substitute in this constraint. So, 24x1 plus 11 of 0 equal to 264. Then 24x1 equal to 264. 24 value, you can find out x1 equal to 264 divided by 24. So, we will get the values of x1 is 11. Therefore, fourth point is d of x1 comma x2 equal to d of 11 comma 0. So this constraint, another 2 points is getting. These 2 points again we need to draw. Already First constraint 2 points we drawn. On that only second constraint 2 points we are going to be draw here. Here we know that for the points A, B, C and D on graph sheet, scale will be 2 units x-axis and y-axis will be considered. Now we are going to use it as graph sheet. Look at that green line, already we found it. Now blue line we can be find it. For the third point is C of 0, 24 and then fourth point is D of 11, 0. Both you had it, you will get that format. In this, both the constraints are less than or equal to, both are will be common area will be shown as it is here, will be this is the area will be common. How do you find less than? Both the constraints are less than. So towards 0, what is the common area? So we get it as common area here 0 and then D and then E and A. This is a feasible region or solution region. Feasible region is O, D, E and A. Is a graph sheet we are drawing. In that E point it will be intersecting. We can use the graph and we'll get approximately E of 6, 12 because it is close to 6 of x-axis, close to 12 of y-axis. So we'll be taking, or we can get the exactly whatever it is there. We are approximately considered as 6, 12. Now the corner points will be getting A of G, H, I. So the corner points are O of 0, 0, D of 11, 0, E of 6, 12 and A of 0, 15. We can use the table and get the values of objective functions. Like this points, coordinates and z value. Z equal to 18 of x1 plus 16 of x2. We are using objective function is here only. O value 0, 0, that is origin. Substitute in that 18 into 0 plus 16 into 0, 0 plus 0 will get totally 0. D, in place of x1 and x2, x1 equal to 11, x2 equal to 0. Z equal to 18 into 11 plus 16 into 0. 18 into 11, 198. 16 into 0 plus 0. So 198 plus 0 equal to 198. E equal to 6, 12. So 18 into 6 plus 16 into 12. 108 plus 192 will get 300. A value is 0, 15. Z equal to 18 into 0 plus 16 into 15. So we will get that here. What is that? 0 plus 240 will get 240. The given objective function is maximum. So in this table, z value which is maximum. So that is the z equal to 300 as maximum. For that coordinate is 6, 12. So that is the solution. Maximum of z value equal to 300. The solution of maximum z is maximum value of z equal to 300. So the solution is maximum z equal to 300. Therefore the coordinates of x1 equal to 6 and then x2 equal to 12. In this way we can able to find out graphical method of the given problem. Here we can going to solve another problem. It is 3 constraints will be considered. Here the same thing only we are going to consider the 3 constraints and the given objective functions and this given problem we are going to solve it. Feasible region that return the large and smallest values of z. Then first step will be inequality will be considered as equation format. So we'll be find out in this inequality x plus 2y less than or equal to 14 converted into equation x plus 2y equal to 14. Put x1 x equal to 0, 0 plus 2y equal to 14, then 2y equal to 14, then y equal to 14 by 2, then y equal to 7. Therefore the first point will be a of x comma y equal to a of 0 comma 7. Then similarly y equal to 0 will be substitute. X plus 2y of 0 equal to 14. Therefore x equal to 14. Therefore the second point is p of x comma y equal to p of 14 comma 0. For this will be as it is. First constraint will be x plus 2y equal to 14, so that a value is 0 comma 7, b value is 14 comma 0. Here axis of both is unit 1 only, enough one unit will be considered. Come to the second constraint. Second constraint 3x minus y is greater than or equal to 0. Convert into equation 3x minus y equal to 0. Put x equal to 0. 3 of 0 minus y equal to 0. Therefore, y minus y equal to 0, y equal to 0 will get. So, the third point is c of x comma y equal to 0 comma 0. Similarly, y equal to 0 if you substitute 3x minus y equal to 0. Therefore, 3x minus y 0 equal to 0. 3x equal to 0. Therefore, x equal to 0 will get. Here also the sum point will be same. That means here this line is passing through origin. That is the reason both the points are getting same 0 comma 0. For this graph is we will be getting in the blue color 0 comma 0. C and D points will be same places. Then we'll go to the third constraint. Third constraint will be x minus y is less than or equal to 2. We can convert as an equation x minus y equal to 2. Then put x equal to 0. 0 minus y equal to 2. Then minus y equal to 2. Therefore y equal to minus 2 will come. Therefore the fifth point is e of 0 x comma y equal to 0 comma minus. Now we are going to find out the put y equal to 0. So x minus 0 equal to 2. Then x equal to 2. Then sixth point is f of x comma y 2 comma 0. Then plot the points a, b, c, d, e and f on graph sheet. Then scale will be considered here as x-axis equal to 1 centimeter 1 units and y-axis equal to 1 centimeter 1 units. Here as this graph will get it here as the second way. Now this is the graph will be getting here. So all the three graphs is getting in this corner point. This is the area will be common because first graph will be less than or equal to. Second graph, that is first graph is x plus 2y equal to 14 will be less than. That's why towards 0 will be considered. Second constraint 3x minus y greater than or equal to 0. That is why to above that we are taken. Then third one again x minus y less than or equal to 2. So that is also will be taken towards 0. So this a common region will be is getting here. The common region here is O, H, G, I. So this region we need to find out what is the maximum value and minimum value. So feasible regions are O, H, G, I. Okay, the points will be considered. The O is 0, 0, H will be 2, 0, G is 6, 4 and I is 2, 6. Based on the graph sheet will be found at where it is locating. Find out the points of G and I. How to find out The here is the two lines intersecting. It is perpendicular to x-axis and perpendicular to y-axis. That is the values of g. 6, 4 will get. Similarly, I 2, 6 will come. X-axis perpendicular to x-axis is 2. Perpendicular to y-axis is 6. So we got it. I of 2, 6. For that, values need to be found. These are the corner points we'll get. That is called visible region. So put the table. The coordinates z equal to 3x plus 4y is the objective function in this problem. 0, 0, z equal to 3 of 0 plus 4 of 0, z equal to both the values are 0. That means z value will become 0. H is x value is 2, y value 0. Substitute 3 into 2 plus 4 into 0. Simplify 6. So therefore, point 2, 0, z value is 6. G point 6, 4 is the coordinates. Substitute 3 of 6 plus 4 of 4 will get 18 plus 16 will get 34. So z equal to 34 of coordinates 6, 4. Then I 2, 6. For that z function 3 into 2 plus 4 into 6, 6 plus 24, 30. In that maximum value is z equal to 34. So the solution will be talking about maximum value of z equal to 34. Then we can find out as solution is maximum z equal to 34. For that x value is 6, y value is 4. In this way, there are two problems I explained. One is 2 constraints, another one 3 constraints. Any number of constraints doesn't matter. Variable should be 2. Then we can solve in this format. This is the way we need to be solved it. First we need to find out the points, then plot on the graph, then find out the common region for all the conditions of the constraints. Then we can get a feasible region. From there, corner points is selected. Then put the table. What is the maximum? If it is given minimum, z equal to 0 here. So we have to take x equal to 0, y equal to 0. Maximum z equal to 0. That's the minimum. All the problem will not be the same. We'll get each problem has different ideas. Okay. To find first formulation of LPP, then we're going to solve by graphical method. First one you see x1 will be the number of tables, x2 be the number of bookcases, because here they said they found it as a 100 square feet plywood and scrap and 80 square feet of the white pine scrap. So in a usable form, that is what we are going to study. Here amount and profit always will be a objective function. So will be considered as maximum z equal to 25x1 plus 20x2. Here conditions is what is given here. 16x1 plus 12x2, 16 square feet of plywood and 8 square feet of white fine. So square feet of plywood, how much is that? 16 one is that, 12 is that. That's the reason 16x1 plus 12x2 is available is 100 square foot. Now fine you have to take the white fine. 80 square feet is available. In that, first one will be prepared by 8 square feet, second one will be prepared by 16 square feet. So first two you have to consider as plywood, second one is white fine. So separately we are considered 8x1 plus 16x2 less than or equal to 80. Availability is 80. Therefore the condition is x1, x2 greater than or equal to 0. This is the way we need to make a formulation. Once formulation is over, then we can solve by graphical method. We know already, we studied that first constraints we need to consider and then put x equal to 0 and second variable equal to 0, we'll get it. Here we studied, see, plot the constraint on the graph. Temporarily, we will convert the inequalities into equation. First one, what is that? 16x1 plus 12x2 equal to 100. Second one, 8x1 plus 16x2 equal to 80. First constraints will be taken as x1 equal to 0. So we will be consider x2 x1 equal to 0 means 12x2 equal to 100 will come. Therefore, x2 equal to 100 divided by 12. That is equal to 25 by 3. We can write first point will be 0, 25 by 3. Second one, put x2 equal to 0 means 16x1 equal to 100 will come, therefore x1 equal to 100 divided by 16, therefore 25 by 4. So 25 by 4 comma 0, it is a second point. Take this second equation, 8x1 plus 16x2 equal to 0. Put x1 equal to 0. So 16x2 equal to 80, therefore x2 equal to 80 by 16, that is 5. x2 equal to 0 is substitute. 8x1 equal to 80, therefore x1 equal to 80 divided by 8 equal to 100, or the point will be 10 comma 0. These 4 points, what are the 4 points? 0 comma 25 by 3, and then 25 by 4 comma 0, 0 comma 5, 10 comma 0. All these 4 points plot on the graph we will get in this format. In this common region is O, and then here the point B and C. O, A, B, C. This is the common points will come. So in that we can able to find out the format. O, A, B, C in the graph satisfied the constraints shown by that. So center point coordinates Z. First is O, A, B, C. O is the 0 comma 0. Substitute, you'll get everything, will get 0. 25 into 0 plus 20 into 0 equal to 0. A, 25 by 4 comma 0. 25 into 25 by 4 plus 20 into 0. So simplify, 625 divided by 4 equal to 156.25. And then B point is 4 comma 3. 25 into 4 plus 20 into 3. So you will get it as 25 into 400. 20 into 3 plus equal to, will get 160. Then 0 comma 5. 25 into 0 plus 20 into 5. We will get 100. So maximum value will get as a B point 4 comma 3. So maximum Z equal to 160. Then x1 equal to 4, x2 equal to 3. This is the way we can able to find out formulation, then solving the graph problem. So we'll see another one problem. It is given in the problem like furniture manufacturing enterprises will be followed by chairs and tables are preparing. Wood will be, and labor will be, availability is there. Wood will be 300 square feet will be, labor is 110 is there. What is the conditions? Here Z functions will be profit basis only we need to consider. Always profit or two different things, table and chairs. So let x1 be the number of tables, x2 be the number of chairs. So Z equal to 6x1 plus 8x2 based on the profit or two different products. Subject to conditions. Wood we are considering. Wood is table preparing 30, chairs preparing 20. Availability is 300 square feet. Then labor is 5, table preparing, and then chair preparing 10. So availability is 110. So x1 and x2 greater than or equal to 0. Again the same procedure will be taking us. So these two constraints will be taken. x1 equal to 0, the value will get 0 comma 15. x2 equal to 0, x1 equal to 10, so 10 comma 0. So we substitute, will get this graph sheet for the 2 points. In order to plot the constraints on graph, temporarily we will convert into the inequalities into equations. Then second equation will be 5x1 plus 10x2 equal to 0, x1 equal to 0, x2 equal to 110 divided by 10 equal to 11. So simplify, you will get 0 comma 11. x2 equal to 0, so we will get it as 110 divided by 6, 5 equal to 22, 22 comma 0. This is the way we can find out. The previous diagrams I'll show it again. See, this is the way graph will be followed. Then middle point, whatever you are getting, and then you get that point will be find out. So feasible reasons here, O, A, B, C. O is 0 comma 0, we know very well. A is 10 comma 0, B is 4 comma 9, and C is 0 comma 11. Substitute that, in that the values will come. 0 comma 0 if you substitute, 0 will come. 10 comma 0 if you substitute, 60 will come. 4 comma 9 if you substitute, you get 96. 0 comma 11 if you substitute, will get to 88. Mean that maximum is 96. Therefore maximum Z equal to 96. x1 of that value is 4. x2 of that coordinate is 9. Therefore the solution is maximum Z equal to 96. x1 equal to 4, x2 equal to 9. In this way, we can able to solve the graphical problem. Now, another problem I am going to explain. A company products of two types, A and B, that is called objective function. x1 and x2 will be the company two types pen A and B will be considered. A is a superior quality and B is a lower quality. Profit of pens A and B is 5 and B is 3. So 5x1 and 3x2. That is the two different products. And the raw materials for each pen is twice the pen B. So x1 of A will be the twice of x2. That is the one will be given as is A is twice and B is once. Therefore, x twice of x1 plus x2 will be getting here. Then similar way we can find out 100 pens type per day. Pen A requires a special clip and only 400 such clips are available per day. Pen B only 700 clips are available per day. 400 for first pen A, then 700 for second pen A. This is the one. Now we will take consideration. Let x1 be the number of type A pens, x2 will be the type of B pens. The mathematical formulation, here we know profit oriented only, maximums that equal to what are the two different types of pens will be using, A and B, 5x1 plus 3x2, subject to the constraints. First one, A is twice raw material is required and B is only once enough. That is the reason twice of x1 plus x2 is less than or equal to 1000. 1000 is availability. x1 preparing is availability is 400. x2 preparing is 700. Therefore, x1 comma x2 is greater than or equal to 0. That is constraints condition will be used. Now, first constraint will be considered and will be used in an. There are given constraints we used as the given constraints will be written in the equation form. First one only will be considered. Second and third one directly the values are getting. First constraint, put x1 equal to 0, x2 equal to 100. Second one, x2 equal to 0 will get x1 equal to 500. So first point is 0 comma 1000. Second point is 500 comma 0. So we'll be plotting the graph. The slanting line will be first constraint. Second one is x1 equal to 0, x1 equal to 400. 400 values will be vertical line will be put. Second one x2 equal to 700. So horizontal line of perpendicular to y-axis we put x2 equal to 700. In that common region, because everything is less than or equal to the common region, what I shown in the figure, you will get it. In this figure, we will get that. What is that? By plotting the above lines on the graph, we have satisfied the conditions. The common region is or feasible region is OAD, ODABE. This can be evaluated. Look at that ODABE. O is 0, 0, D is 400, 0, A is 200, 400, B is 150, 700, E is 0, 700. Substitute the values. 0, 0, if you substitute 0 will get 400, 0, if you substitute 2000 will come. 200, 400 if you substitute will get 2200 will come. 150, 700 if you substitute 2850. Then 0, 700 if you substitute will get 2100. That maximum is 2850. That is the maximum z equal to 2850. For that coordinates is x1 equal to 150, x2 equal to 700. This is the way we can able to find out the graph method of solving the LPP programming problem. In that above we will be finding as the evidence of that 2500 at point B. Another problem will be considered here. Here you see that here again the problem is given. There is no only x1 and a number x2 is produced. The maximum value is 375 by divided by 25. If only x2 number of is produced, then you can able to draw in that. Here another problem we are going to see. Here maximum z equal to 18x1 plus 16x2 subject to the constraints 15x1 plus 25x2 less than or equal to 375. Next constraint 24x1 plus 11x2 less than or equal to 264. If only x1 and x2 is produced, the maximum value of x1 is 375 divided by 15. You will get 25 if you solving that. If only x2 and no x1 is produced, that is mean put x1 equal to 0, you will get x2 value. Put x2 equal to 0, you will get x1 value. In that way only calculated. x2 you will get 375 divided by 25 equal to 15. This already we have seen so many problems. So then we are going to calculating now directly the values of x1 and x2. A line drawn between these points. What is the points? First one, when you put a y equal to or x1 x2 equal to 0, you will get the point 25 comma 0. If you could give x1 equal to 0, the point will come 0 comma 15. Represent this constraints factor 15x1 plus 25x2 less than or equal to 375. Any point which is lies on or below this line will satisfy this inequality and the solution will be somewhere in the region bounded by 8. Similarly, the line for the second constraint 24x1 plus 11x2 less than or equal to 265 can be drawn. The polygon OABC represent the region of values x1 and x2 that satisfies all the constraints. This polygon is called the solution set. The solution to this problem is exhibited graphically. Graph is drawn. We are drawn. See that the two lines. Okay, there is a two lines. One is 0 comma 15. Another one is 25 comma 0. Then third one is 0 comma 25. Another one is 11 comma 0. So we have found it. In the shaded part is the feasible region O, A, B, C. Then the end points are corner points, shaded area 0 comma 0, 11 comma 0, and then 5.7 comma 11.58. We can take approximately 6 comma 12 and 0 comma 15. So we can find out there we'll get x1 equal to 5.7 approximately 6 and x2 equal to 11.58 and z equal to 288. This is another one feasible reason. This problem already we solved that we have taken approximate value. Here exact value we have taken. When you are using the graph sheet, we will get exact value. Then another example will be considered 2x1 minus x2 less than or equal to 2, which passes through the lines. Similarly, x1 equal to 0 you put and x2 equal to 0 put, we will get 2 points 1 comma 0 and 0 comma minus 2. Any point which lies on or below this line satisfies inequality of the solution will be found it. The region bounded by it. Similarly, another one x1 less than or equal to 3. Here no x2 values. This is called as a straight line. x1 equal to 3 you have to draw. That's enough. This optimal lies on one of the corner points of the dark shaded portion bounded by these straight lines. This is what we are going to see in the next diagram. Look at here the diagram which says that first constraints will talk about that. The points is 1 comma 0 and 0 comma minus 2 extendable. Then another one will be x1 equal to 3 vertical line parallel to y-axis. Then common region both are less than or equal to, so shaded part will come as a common region. So optimal solution is here. There is only one point maximum z you will get. So x1 equal to 3, x2 equal to 4.2, which is intersecting. which is located in the graph is P. Maximum value is, substitute x1 value is 3, x2 value is equal to 4.2, in z equal to there 6x1 minus 2x2 will get it as 9.6. After substitution we will get these values. Now another multiple optimal solution method of that. Here you see so many questions constraints are given, then how to find. That is what we are going to use. So first one, x1 less than or equal to 80, x1 equal to 80, 80 we have to put vertical line parallel to y-axis. x2 less than or equal to 60, it is parallel to x-axis, perpendicular to y-axis, we will write as x2 equal to 60. Then another two constraints we have to put, x1 equal to 0, 6x2 equal to 600, therefore x2 equal to 100. If we put x2 equal to 0, 5x1 equal to 600 divided by x1 equal to 100, 100 comma 6, that means we'll get a year as called as 12 comma 6 will come. Okay, that is we'll get as a 12 comma 6, 120 comma 60, we will get it as 100. So we can find out in these places. Similarly, x1 equal to 0, x2 equal to 0, if you substitute, another line will come. The graph will be as shown in this figure, will get in this format. In the above figure, there is no unique outer most corner cut by the objective function line, because there are so many lines will be getting. All points of P and Q lying on the PQ represent the optimal solution. All these will give the same optimal value of profit rupees 160, because P point also Z value will get 160 and Q point also will get 160. So both maximums are same. That situation, this indicate multiple optimum solution. This indicate by the facts that both the points P with the coordinates 40, 60 and Q with the coordinates 60, 50. Both it is satisfied. x1 plus 2x2 equal to 160. Thus, every point on the line PQ maximized the value of the objective function. That means these 2 points P and Q will give maximum values of Z. So this problem has multiple solutions. When we will say the multiple solution, when it is getting maximum Z equal to same values in two different points. Here two different points is P and Q. P and Q values of x1 and x2 will give maximum Z equal to same value. That is the reason this problem will say multiple optimal solution. Now, infeasible solution. In some cases, there is no feasible area because we cannot able to make a corner points. There are no points that satisfies all constraints of the problem. An initial infeasible LP problem with two decision variable can be identified through graph. For example, where we consider here, see that this problem 200x1 plus 300x2 subject to the constraint 2x1 plus 3x2 greater than or equal to 1200, x1 plus x2 less than or equal to 400, 2x1 plus 1.5 x2 greater than or equal to 900. This point, same way, put x1 equal to 0, y1 x2 equal to 0, you get 3 constraints, 6 points. 6 points will be considered on drawing the graph. The graph will be shows like those: greater than, less than, greater than. There is no common area. Arrow mark shows that greater than means upward, less than means downward. There is no common area for all the three constraints. There is no common region. Then we can say it is infeasible region. Here explanation is gone. The region located on the right of PQR includes all solution which satisfies the first and the third constraints. The region located on the left straight line in ST include all solution which satisfies the second constraint. Thus the problem is infeasible because all the three constraints are not satisfied. There is no set of points that satisfies all the three constraints. This is called infeasible problem in linear programming problem. Then unbounded solution. We cannot able to bound it in the proper way. It is a solution whose objective function is infinite. That means we cannot able to, everything is greater than means it's going on, but we cannot able to find out. That's what he is saying here. Minimize z equal to 40x1 plus 60x2 subject to the constraints 2x1 plus x2 greater than 70, x1 plus x2 greater than 40, x1 plus 3x2 greater than 90. So x1 and x2 must somewhere in the solution phase shown in the figure. Somewhere, but where is exactly? No. Unbounded means we cannot able to find out a corner points or feasible region completely. See, p equal to 90 comma 0, q equal to 24 comma 22, r equal to 0 comma 70. The values of the objective function at these 3 points are set of p equal to 3600, set of q equal to 2280, and set of r equal to 4200. But maximum another corner, lower part is getting, upper part is not able to get it. That kind of problems is called as unbounded solution. Unbounded solution means we cannot able to make a boundary of the given problem. Then you can say it is called as unbounded solution. Thank you for watching my videos. Any doubts or any clarification, you can call me and you can directly ask me the questions. Any clarification and doubts. Thank you for watching. I hope you are all using my videos for the best of your knowledge. This video will end today, unit number 1. We will see in the unit number 2. Thank you for watching. Any feedback can be welcome.